Today we are going to be talking about using the commutative property, associative property, and distributive property to simplify expressions. We will also be looking at combining like terms. Let's talk about the commutative property of multiplication and addition to start with. So really what this property is saying, and if you ever hear about a commutative property, saying that order doesn't matter. So thinking about if you add two numbers together or if you multiply two numbers together, doesn't matter which one you do first. 2 plus 3 is the same as 3 plus 2. 2 times 3 is the same as 3 times 2. You get the same answer. This is the commutative property of multiplication and the commutative property of addition. This is how we would show this algebraically to make a statement so that we can put any number in here to say that it's true. So this is just modeling that a plus b is b plus a for any values for b and a. Same thing. A times b is equal to b times a for any values of a and b. Go ahead and write those down in your notes. We also have the associative property of multiplication and addition. Now this is a little different because instead of focusing on the order that we add and multiply, we're talking about grouping things together. So the associative property of addition says we can group things in any order that we need to. So looking at this first example here, you'll notice that in the first side of the equation, I'm looking at b and c, and I want to focus on adding those two together. On the second side of the equation over on the right, I'm going to focus on adding a and b together first and then adding c last. Same idea with multiplication. I multiply bc first, then a. On the other side, ab first, then c, but showing that it's equal either way if you do this. Let's look at some examples to see how we can use the commutative property and associative properties to our advantage. Example number 1 here, 4 times 9 times 25. Now, if we think about typical order of operations and you think about how you usually multiply left to right, although we know because the commutative property, the order we multiply these doesn't matter. So we can look to be strategic and see, is there something that we can do quicker or that we can do in our heads then, and look for ways that might make this problem a little bit simpler. So noticing here, I have 4 times 9, which would be 36, and then I have to do 36 times 25, which is going to take me a little bit of effort, or I'm going to have to grab a calculator. Versus if I look at 4 times 25, and think about this instead as 4 times 25, then times 9, think about it as having 25 quarters. Think about having 4 quarters, 25 cents, right? If you have 4 quarters, how much do you have? It's in groups of 100 now. So we have $1 or 100. 4 times 25 is 100. Times 9, well, I can now do this in my head. A problem that I would have had to write out 36 times 25 is now done pretty simply. Same idea here with addition. So looking for, usually I like to look for groups of 10. Yeah, I could add 26 plus 2 and get 28, and then add 28 plus 68. But if I notice and look for different ways that I can group and make a nice even number, I can do 68 plus 2. Remember, order doesn't matter because of that commutative property. And get a nice even 70. Well, 70 is a lot easier to add to 26 than 28 is to 68. Just looking because I have that basis of 0 there. There you go. We also have what we call the distributive property. Now, the distributive property is our link between addition and multiplication. If I'm going to multiply a times the sum of b plus c, then I can also look at that distributing it. It's like breaking it into 2 parts. So a lot of times you'll see us use these arrows there. So a times b, a plus c, and you see that shown here. We can use that in different ways when we look at multiplication problems. So I can actually break this problem apart. Instead of just going 12 times 103, like we did in the last problems, I can look to make this an easier problem. Breaking 103 into 100 plus 3, all of a sudden, this is something that I can do a little simpler. 100 times 12 is 120. 12 times 3 is 36. Adding those together, I get 156. Same idea if we want to use subtraction for this. The distributive property, we can rewrite this as adding or subtracting. So I'm going to do 16, and this time I'm going to go with 20 minus 1 to represent 19. Same idea here, but once again, trying to make the problem a little bit simpler. So if I distribute, 6 times 20 is 120. 6 times negative 1, I'm going to be subtracting 6 then. I get 114. Sometimes you'll see this done with variables, and this is one way that we can go about simplifying and looking for a way to rewrite an expression and identify like terms, which we'll be talking about in a little bit. But same idea here, but now we'll be looking for our coefficients. Negative 2 times 6 is negative 12. Negative 2 times x, you can do plus negative 2x, or if you want to clean that up and maybe write a little simpler, you can write minus 2x. Adding negative 2x is the same thing as subtracting 2x. Last example here. Distributing, making sure we multiply the 3 by both things inside. So 3 times 2x is going to give us 6x. 3 times negative 1, negative 3. A coefficient. I'm going to want to pause and write this down as well. A new vocab word for you if you aren't aware of this already. A coefficient is a number that is multiplied by a variable. So looking at my examples right here, I have 2 different expressions. Let's focus on the first one over on the left here. Now, all my variables, I've got x and y. Those are my variables. So we're looking for the numbers that are right out in front being multiplied. So here, my coefficients are 3. The coefficient of 3x is 3. The coefficient of y is 5. And the next example here, you'll notice that you don't actually have something in front of the x. But whenever you see a variable that doesn't have a coefficient in front of it, remember that it's actually the same thing as being multiplied by 1. So our coefficient in this case, when we just have x sitting here right here, the coefficient is 1. One thing we also have to pay attention to is we're subtracting 4y, but that negative symbol, that subtraction, sticks with the y right there. So we need to make sure that it's not just a coefficient of 4, it's a coefficient of negative 4. Like we did in the last example, subtracting 4y is the same thing as adding negative 4y. So my coefficients here are 3 and 5. My coefficients on the second expression are 1 and negative 4. Terms. Terms are part of an expression that are added or subtracted. Once again, I have a couple different examples here, and we're going to look at how many terms we have in each expression. So in this first expression here, I have 2 terms that are connected by an addition sign. In the second example, we're looking for all of those addition or subtraction signs. That's what separates the terms. So you'll see the 2 and the 3x are separated by this negative sign. And in between this 3 right here and the x is another plus sign. Sorry, the 3x and the 3 times x minus 4. That whole last term there is all together because it's being multiplied, not added or subtracted. So we have 3 terms in the second expression. Now, like terms are terms that contain the same variable that are raised to the same powers. All constants are also considered like terms. So we talked about constants earlier. Constants are just numbers. So any number, they can just be added together as long as they don't have a variable that they're being multiplied or divided by. So looking at our first example here, I have 3 terms, 4x, 3x, and 2 that are being separated by addition or subtraction signs. And on the right there, I have 1, 2, 3, 4 terms, 6, y squared, 2y, and 3y squared. We're going to go ahead and look to see identify our like terms. They need to have the same variable raised to the same power. You'll notice that we have x in both of these terms. So those would be considered like terms. And on our second example, I'm looking for same term raised to the same variable raised to the same power. So y squared and 3y squared are like terms. 2y is going to be left out of this because it's not raised to the second power. To combine like terms is when you identify your like terms and then add or subtract their coefficients. So trying to simplify it. So when I have my like terms, I have 3 terms in my first example, 12x, 30x, 4. 2 like terms, both have the x variable. To combine them, I'm just going to add their coefficients. So I have 12 plus 30, which is 42, and the variable stays the same. This is how you can simplify an expression by combining like terms. 42x cannot be combined with 4 because one has an x variable and one is a constant. The next example here, I have a bunch of y variables. It looks like I have 1, 2, 3, 4 terms, y squared, 3 or negative 3, 2y squared or negative 2y squared. However you want to look at it. You want to think of it as plus negative 3, minus 3, or plus negative 2y, or 2y squared, or minus 2y squared. I see two variables that are raised to the same power, and whenever I'm circling my term here to combine, I'm going to keep that symbol of a negative in front with it because it gets attached to that 2. So when I combine y squared with negative 2y squared, I'll end up with negative y squared. So remember, this is like having a coefficient of 1. So 1 plus negative 2 is negative 1, or negative y squared. I can't combine the 2y with that at all, so that's just going to stay the same. And the negative 3, the constant, is going to stay by itself as well. Now, if you don't have a highlighter to show your work in this way, what you can do as well, you can always just circle what you're going to do. So if I have, for example, 12x squared plus 6x plus 7 minus 3x squared. If I don't have a highlighter to show where I'm combining my like terms, another option you have is to circle them. I know some people also like to underline them. So let's say we also have a 2x. So if I circle those two to show those are like terms, another option I could have is that maybe I underline these other like terms. We just have to make sure we keep track of all of our terms and we don't lose any when we start to simplify, that we don't lose track of them. I can't forget that I've got that 7 there. Even though it isn't being combined with any because it doesn't have like terms, I'm still going to have the 7 at the end. 12x squared minus 3x squared is 9x squared. 6x plus 2x is 8x. All we're doing is combining the coefficients. There you go. That's how you combine like terms. If you have more questions about this subject or anything that's been talked about in this video, make sure that you reach out to your intermediate algebra teacher.